Let's investigate replication and sharding further. Replication involves creating multiple copies of the data across different nodes, enhancing fault tolerance. Sharding, on the other hand, divides the dataset into smaller, manageable pieces distributed across nodes, improving parallel processing capabilities for faster search operations. These are architectural decisions to ensure availability through distributed architecture. Service discovery enables Vald components to automatically locate each other within the distributed system. etcd and console are popular tools used for this purpose. They provide a central registry where services can register themselves and discover the addresses of other services. This dynamic discovery enhances the system's flexibility and resilience, allowing nodes to join or leave the cluster without manual reconfiguration. This refers to an individual instance within the Vald distributed system. Each Vald node is responsible for storing a subset of the vector data and performing AND searches on that data. The distributed nature of multiple Vald nodes increases both the system's capacity and its availability. Here we are looking at Vald node 1. It represents a specific server or process within the Vald cluster, contributing to the overall search and storage capacity of the system. This refers to another node in the Vald cluster, working in conjunction with other nodes like Vald node 1 to handle vector storage and AND searches. Vald node n represents the concept of scaling the Vald cluster to an arbitrary number of nodes. This highlights Vald's ability to handle large datasets and high query loads by adding more nodes to the cluster. N signifies that the architecture supports horizontal scalability. Each Vald node in the cluster performs approximate nearest neighbor, AN, search on its local subset of the vector data. This parallelization of the search process across multiple nodes is crucial for achieving high query throughput and low latency, especially with large datasets. This is about availability through distributed architecture as well as Vald advantages, AND search. The storage layer represents the underlying storage mechanism used by Vald to persist the vector data. This could be a variety of storage systems, ranging from local disks to distributed file systems or cloud-based storage services. The choice of storage layer impacts the system's scalability, durability, and cost. Vector data refers to the numerical representations of data points, often generated by embedding models. These vectors capture the semantic meaning of the original data and are used for similarity search. Vald stores and indexes these vectors for efficient retrieval. This highlights one of Vald's key strengths, its distributed architecture, which ensures high availability and fault tolerance. By distributing data and search responsibilities across multiple nodes, Vald can continue to operate even if some nodes fail. This relates to availability through distributed architecture. Let's zoom in on load balancing. It distributes incoming search queries evenly across the Vald gateways or directly to Vald nodes. This prevents any single node from becoming a bottleneck and ensures that the system can handle a high volume of queries. Okay, let's break down client applications. These are the applications that use Vald to perform vector similarity searches. They interact with Vald through the provided APIs, gRPC, REST. gRPC and REST are the communication protocols used to interact with Vald. These APIs allow client applications to send search queries and receive results from the Vald vector database. gRPC is known for its high performance, while REST is widely adopted and easier to integrate with various systems. Let's discover the Vald gateways. Vald gateways serve as the entry point for client applications. They handle request routing, load balancing, and authentication, providing a secure and efficient interface to the Vald cluster. Monitoring dashboards are super important for observing the system. These dashboards provide real-time insights into the performance and health of the Vald cluster. They display metrics such as query latency, throughput, resource utilization, and error rates, enabling administrators to identify and address potential issues proactively. This indicates another individual server within the Vald network, emphasizing the scalability of the system. Again, this refers to the entry points into the Vald system for search queries, potentially highlighting a multi-gateway setup for increased throughput or redundancy. Multiple gateways are essential for managing load and maintaining service availability, acting as intermediaries between clients and the core Vald nodes.